and welcome to lesson 15. The plan for today is to hopefully get this layering working out. So when we're down here, we render in front of it, sort of like a tower, and then get to some collisions, which should be fun. So anyway, let's jump right into it. Let's start with the layering, and to test this out, what I'm going to do is actually going to load. I think it's from, yeah, I'm going to go ahead and load a few more tiles from here. We'll go ahead and just load the tree. So if you don't remember how to do this, because I know it's been a while since I've actually added tiles, all we gotta do is go into the tiles.txt here, and it looks like I'm gonna have to open it in Sublime Text because Notepad does not know where the spaces are. And we want tree top to be, let's see, 0, 1, 2, 3, 4, 5 in. So tree top is 5, and then 0, 1, 2, 3. Okay, and then we want tree bottom. That is 5, 4. 1, 2, 3, 4. So there we go. Let's save that and then run our game. And we should see our tree here that we can place. And I'm still editing on layer 2, so I went ahead and I've placed these trees on layer 2. Just that was like what for now I've got hard coded. So anyway, what we're gonna work on today is, okay, fine, rendering behind the tree is what we want, or behind it. But when we are in front of it, we want to be rendered in front of it. So like if my feet are below it, we want to be rendered in front of it. And just to show you that I have actually got this working, in one of the, to give you another example here, let me go ahead and open up this. This is just like part of my notes, but over here, is sort of an example. I'm rendering behind it here, but when I'm in front of it, I'm rendering in front of it. So yeah, hopefully we're going to get some advanced collisions done today as well, but the first thing we're going to work on is layering, as I promised in the last, advanced layering, as I promised in the last episode, last lesson, episode, whatever. Let's go to our code here. And there's a few things we're going to need to look at today. We're going to have to look at our map, actually mostly our map. So let's open this up, and let's, I also forgot one thing, and that was to actually zoom in, which was helpful for people who went in theater mode last lesson, because it's been a while since I made a lesson, so sorry about that. I did forget that I needed to do that, so it was easier for you guys to read. But if you made it full screen, you'd be able to read it, or made it big enough so that you could. So let's look at how we're rendering our layers here. So down here, for each layer, we have this hybrid approach to our blocks. Sorry, I'm already thirsty. Happens when you start talking and you haven't been talking for a while. And we don't have to change anything when it comes to this approach. The only thing we have to do is change when we are rendering our objects, depending on certain aspects. So this is fine. This is if the layer is the max value. So if the layer actually isn't even set. I guess we could also do like these are the two possible possibilities for layering, rendering afterwards. If it's -1 as well, maybe. Maybe that just means it's not even in a layer. Although maybe, you know what? No, I'll keep that as a special case, because if it's -1, maybe it's a game object that we don't want to have on a layer. That sounds like it would be like something that doesn't even render, you know. So this is really this approach is actually pretty simple. So all we need to do is where we have objects i.getLayer equals layer, we want to add an else down here, and else will be if objects i.getLayer equals layer plus 1, right? So if it's the layer, this object is below this layer. Which is the case for our player when we're in front of the tree. And what we want to do is check to see if and I'll run the game so I can actually show you this. We want to check to see if our player is standing below, if the feet, the tile the player is actually standing on is non-existent. So here's an example. If we had a tree head there, then technically we would render in front of it. And I think we're gonna make that a general rule, not to place Actually, yeah. So, well, one thing at a time. I just had another idea, but one thing at a time. If the tile below this one is empty for now, we'll just go ahead and say if it's empty. Let's go to map, and well, we really all we need to do is get the tile below from the block. So let's see. Think about how we're gonna get the tile below the player. Let me open the game object to see what I have access to. Do I have access to a rectangle or anything at all? Okay, so that's a method we're gonna have to make. We're gonna have to make the game object get rectangle method. So private rectangle or private public rectangle get rectangle, and this means we are gonna have to. Ooh, map.java uses unsafe. Oh, that's right. So where we have the there's some unsafe operations we'll ignore soon. But anyway, we have to go to game and see what that affects. It'll definitely affect player.java. All we need to do, we already have the player rectangle. All we need to do is add that method. So public rectangle get rectangle, return player rectangle in the player class. What other game objects do we have? I think it was GUI button. An SDK button will override that, so we don't need to re-add it. Let's open both these up. So GUI, we have a rectangle as well we can return, so public rectangle get rectangle, return rectangle. Was it rectangle or rect? Rect. GUI button, we need the same thing for its rect. And obviously we're not actually, these won't actually matter. And just to make sure that everything works fine, I want to go ahead and java c star.java. Animated sprite. That's right, I forgot about that one. Animated sprite doesn't really have a rectangle, but I don't think that's how this is being used. So we'll just go ahead and have public void get rectangle, public rectangle get rectangle, which will return null. Called get rectangle of animated sprite. This has no meaning here. Okay. Alrighty, sorry, I am now back. So let's go to. Well, we've got the get rectangle set and everything. Let's go ahead and make sure that that is actually all set, except for a missing semicolon, which is the bane of my existence. Okay, now we should be good, right? Right, Java? We're good? Alright. Yeah, let's fix this unsafe operation, because that's going to annoy the heck out of me. So it's over here where we are creating an array list, and it's technically unsafe, but we can just go ahead and do suppress warnings unchecked without a semicolon. And that should... Okay, hold on. I gotta figure out exactly how where that's happening. Okay. Xlint unchecked. 358, which is this method as well. So an add tile. Oh, we could just go ahead and do suppress warnings for the whole block as well. So like that. Now that unchecked thing is gone. You don't always want to suppress warnings, but in this case we are dealing with an array of array lists, and we're using it correctly. It's just we can't create a new array list array with a generic type in it. So technically it's unsafe, but we're good. As opposed to C warnings, Java warnings are not usually that important. Sometimes they are, but not as often. Okay, so I'm getting rid of some of these comments as well. So we were else if the objects that get layer equals layer plus 1, we have this get rectangle method. We want to go ahead and wait. Yeah, okay. So first of all, rectangle, we'll get the rectangle first. And the rectangle, what we'll do, tile below x. It's going to be equal to rect.x plus, actually it's just going to be rect.x divided by tile width, tile width, which gives us the tiled position of the x, because the integer precision is lost there, which is what we want, or the double precision. And then we want tile below y, which is rect.y plus rect.height, and technically -1. We might as well do -1 as well, divided by tile height. So this is the tile below x and the tile below y. And we want to get this from whatever block that's in. So to get, and actually we might go ahead and add a get tile method here. Not in block, but in, oh, I zoomed out a little bit. Not in block, but in like the whole thing. So we have set tile. I want to go ahead and add a public mat tile get tile. Int layer, int tile x, int tile y. I think we have a, do we have a get tile method in here? Doesn't look like it. We might have to add that as well. But anyway, what we want to do is, first of all, get the block that this tile is in by, and let me just make sure, let me go get, did I ever do that math before? I'm not sure if I did that math before. Well, it's the tile x divided by the block width, which will give us the block x. So we want to go ahead and do blocks of tile x divided by block width, of tile y divided by block height, dot get tile layer, will be layer tile x tile y. So this significantly reduces the amount of tiles we'll have to loop through to get a tile, by just getting it from the specific block. And then we'll have public mapped tile get tile int layer, int x, tile x, int tile y. So we'll do mapped tiles for mapped tile tile, mapped tiles by layer. We'll do a for each loop of layer if tile dot x equals tile x and tile dot y equals tile y. Return tile, and then return null. Object 296 object, and these should be integers. Object cannot find symbol objects. Objects I. Just on a roll. And then missing return statement on lines 122. Okay, so we want to return that. But we got to be careful here. We want to do block equals this. And then if block equals null, return null, and else block dot get tile. Cool. So this should work. Sorry, I had to take another drink. That should work. Need some testing, like everything, but that should be fine. Now let's go down to... I just realized that I'm currently going through some of the... I'm doing C-style bracketing because I was doing that for a while, so I can go ahead and fix some of that as well to make it a little bit cleaner, because having one over the other is... having like a combination of both is kind of messy. Probably did that a bunch down here, yep. I can go ahead and just fix this off camera real quick. That didn't take too long. Let's go back up to our thing. Where was it? It's in the render method. I went past that. Render. It was here. Okay, so we have the rectangle, we have the tile below X, and now we have the tile below Y. And what we want to do is if get tile of tile below of layer, which is our current layer, tile below X, tile below Y, equals null. So if the tile below us doesn't exist, then we want to go ahead and objects I dot render. We want to render above this. Okay. Let's see if that works. So if we run our game, I should still render okay, looks like something there is not quite working the way I want it to. So let's go ahead and do some prints. Prints always help. Let's see. Rect.x. We'll just go ahead and do system.out.print line. Tile below X plus tile below Y. A lot of space there for to be clean. Oh, and it's never getting there. So that might be why. So if the... Oh. If objects I.getLayer plus 1 equals layer. I put the plus 1 in the wrong place. So right now it's just app.java 121. Okay, another thing we need to do. If int block y equals tile y divided by block height. I wasn't quite careful enough here. And if block x is less than 0, or block x is greater than or equal to block.length, blocks.length, or block y is less than 0, or block y is greater than or equal to blocks 0.length, return null. And then we pass just these parameters in here, block x and block y. So right now it's just doesn't seem to be working at all. So, and actually I think I might know why. I forgot to offset by the minimums. So let me go back to map. The block x is tile x. Yeah. Tile x minus block start x. And then minus block start Y. Huh. Somewhat working. Might be to do with the player rectangle as well. Maybe. Let's see, how are we doing those calculations? Plus rect.height. And is this rectangle zoomed? I forget if this rectangle is zoomed. I don't think it is, actually. That might be why. Let me go to player and just see if I can figure out if it's zoomed or not. Yeah, that's not zoomed. The X and Y are gonna be the same. But the it's definitely not zoomed. So I want to do rect.height times. Oh wait, do I care about it being zoomed? I shouldn't, should I? Yeah, I shouldn't care about it being zoomed. Oh no, I should because I'm dividing by a zoom here. So rect.height times y zoom. Okay, and that's not quite what we wanted. Yeah, something's going on here. And 1, 2. Something's definitely going on here. I don't know if that's, I don't think it's actually going to do anything, but the plus one there. Minus 1. Yeah, it's energy precision, so it's not actually going to do anything. Not sure why I'm even checking. There's something, I think maybe the getting of tiles is 1 off, because if I'm standing on that tile, I think it thinks I might be standing on like that tile. Or wait, what? So also the X positions are definitely a little bit off. But wait, if I am placing things on layer 2 right now, right? Yeah, so why is it... So that's the tile that for some reason my position is at. That's confusing. So what's happening here? Alright, I'll take a look and be back. Well, I think I found possibly the problem. In the player class, the player rectangle is not 20 by, is not whatever it was. It's actually 20 by 26, and I had it as far as the width and height goes, and I had it different. And that should fix, hopefully, the problems. Close. There's still some, actually, no, it looks like it's working. Okay, so over here we are, alright, cool. Another thing I did, it's not probably going to work for you. Wait, why is that happening now? The heck? Why is... It's not very consistent here. Wow, I thought I fixed the problems. Apparently not. Maybe it'll help if we move our X to the center as well. Because I think our X is a little bit off. Let's go ahead and go back to the map here and make X plus rect dot... Yeah, we'll do this. Rect dot X plus rect dot width times X zoom divided by 2. There we go. It doesn't solve what's happening here. I don't really know what's happening there. Seems to be working all right here. And here. Obviously collisions are not enabled right now. I don't have them created yet. But here it's having some issues. So if I place another tile there. Oh wait, is it having issues with just a little bit off? I think, let's go back to map here. Oh, by the way, what I did, there's two problems happening here. So I went to the the get tile method and just made it loop through all the mapped tiles for debugging purposes to remove what possibly could have occurred in the get tile method. It just loops through the tiles, returns if the layer equals, the X equals, and the Y equals for a tile, it'll return it. We're gonna fix that soon. We gotta focus on one problem at a time with this. So let's go back down to. Gosh, I lost where I was. That's here, I think, where we want. Yeah. So it's just like 1 pixel, and actually it might be doing what it's supposed to do, now that I think about it. No, it's not, because this is definitely... That's a whole tile off. Why is it having issues up here? It's having issues with it up here, but not down here. And that just happens to be the case where Y is negative. So something's going wrong when Y is negative. Let's go figure out what could be happening. So if Y is negative, it's rect.y plus rect.height times Y zoom. That should still be working. It's really weird though. I'm not sure why. It's like it's 1 tile off or something when Y is negative. Let me just see. If I'm standing here at 0. It's like there's 2 zeros for some reason. Why is there 2 zeros? I don't need that int cast. Okay, what if we just... No, I don't want to do that. What if we just did this? No, that wouldn't work. Because this is zoomed. This is a zoomed coordinate. That's fine, but for some reason, like on this tile and this tile that I'm standing on and this tile that I'm standing on, it's treating them both as 0. Another way we could debug this is by let's get rid of this print line. We're going to print out the double precision version of this. And things are broken. What's the problem? Tile height times 1.0. Is there there's too many parentheses maybe? I think there are. Yeah, we want to get rid of that. And then here we have too many parentheses as well. Shoot. I think we want to make sure we want to put these in this part in parentheses. So it's doing double math. So I think it runs left to right otherwise. Okay, so there we go. So now, if we are... Oh, maybe that's why. Yeah, okay. It's because I think I know why. Okay. Yeah, let's go to the map again. And what we'll do is double tile below y equals, and we'll put tile below y underscore, and if tile below y is less than 0, so if it's negative, tile below y minus equals 1, I think. Yeah. I think that's what we want. And then this is just going to be tile below y cast tile below y underscore cast to an int. And I've uncommented that other print line. This is 0, negative 1, 1. Why is that not working? Well, let's just... If we had a tree up here... Maybe I did the opposite of what I wanted to do. I think I wanted to add 1. Well, let's... This shouldn't have changed. Nothing down here should have changed, and that's now broken for some reason. Whoa. X is weird as well. Ah! I'm gonna stop recording and make sure I have it completely fixed before I continue. So this part is working now. What I did is I had to do some flooring here instead of, because it was like losing some precision that was actually needed. And I also forgot that our player spans across two tiles occasionally. So we need to check both X and X2, X being the left of the player and X2 being the right side of the player. So pretty much what I do is I have the rectangle here, the tile below X1, or just X, is rect.x, just the left side of the rectangle, divided by the tile width. The X2 is, I'd have to do math.floor of rect.x plus rect.width times xzoom times 1.0 to make it double math, divided by tile width, and we're flooring this and casting it to an integer. Tile below y is just the y position below, and that is going to be math.floor of rect.y plus rect.height times yzoom times 1.0 divided by tile height. And that's all going to be floored, and it's going to be cast to an integer. We're going to get tile of tile below x, layer, tile below x, tile below y, and see if that is null, and do the same except with tile below x2 and tile below y. And if both of those are null, we will render the player once again in front. So this makes it so that even if we're a little bit behind the tree, we'll still render behind the tree. It also works up here. As you can see, I just placed a tree here because I wanted to. But, wait, what? Okay, sorry, that was just because I was in front of it. Okay. Wait, what? 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 Oh, I think I know what's happening here. So our X is over there, and our X2 is over there. So maybe what we need to do... That's interesting, because our X is just off the left of this tile, and X2 is just off to the right of this tile. Maybe we'll just to be sure, we could do 3 X's. One on the left, one on the right, and one in the middle. That doesn't seem like such a bad idea. So what we'll do is int tile below X3. We'll make this, I guess what we could do, so it's in order from left to right. This will be X3, and int tile below X2 will be... and we'll copy all of this, and it will be rect.width divided by 2. so like in between. And then we'll have to do 3 checks. For x2, x1, x2, and x3, and we can go ahead and put these on their own lines. And let's make sure we can't get that same issue. So I can't stand like directly in the middle. Yeah, looks like it's working now. Great. Alright, so now the next problem, which I haven't fixed off camera because I haven't even looked at it on camera yet, is the get tile doesn't seem to be working. At least with what we previously had, it wasn't working. Maybe it does work now. We have get tile. What I did is I did it the old-fashioned way. That's very slow. But we're gonna go ahead and see if we can get the block x. So let's work through this again. If int block x equals tile x minus the block start x divided by the block width. Because this is a tiled position. It should be all right. Let's see if it works. Okay, so we are. It does look like it's actually working now. So it probably was just. I thought it was a. I wanted to. I think the thing is, I sometimes comment things out like that if there's another way to do it that I know works. If there's just to make sure that I narrow down to wherever the error is occurring. So that seems to be working fine. That is awesome. Okay, so we've got that advanced layering finished. Let's make sure we do a few more tests to make sure that is actually happening. So let's do that now. Let's go ahead and save with that, and let's add some trees along here, like so, and then some trees down here, like so. And what should happen is we can run behind the trees, and we can run in front of the trees. Pretty cool. The one thing that isn't going to work with this code, and I want to warn you about this now, is if we have 2 trees like that, right? We are going to render, because we're checking that tile, we're going to render behind this tree. Which what you probably want to do in this case is put this tree in front on a layer above this, and that should fix the issue. If you're planning on doing trees like that. But I mean, if you are planning on doing trees like that, that doesn't actually look very normal. Well, I don't know. As I said, what you'd have to do is put this tree on layer 3, for example. So let me go ahead and show you that. I'll save the map as it is, and then go to Game, and set the selected layer to 2. Okay, and now what I'm going to do is put a tree there. And as you can see, now I'm rendering in between them because this tree is on. And actually, interesting. That's not actually exactly what I wanted. Yeah. I wonder if I can pose a fix for this. Let me think. How could we fix that? I guess what you could do is instead of checking the tile below this one, have some sort of flag set on the tree tile. So let me go ahead and make the selected layer 1 again, which I will. I guess we'll have to make an SDK thing for that soon. But like this bottom tile here, put some sort of flag on that tile in the tiles.txt, which lets it know that it's the bottom of a structure or a building, which means that it actually just checks that tile, not the tile below, and sees if it's a structure at the bottom of the structure, then we will render the player in front of it if its legs are below it, right? But then you'd have to somehow still render the player above the head of this tree. So anyway, that's just the problem I'm going to avoid for now, just because it's a little bit too complex, I think, for our purposes. We've got most of the advanced layering working. The only rule is you can't have two structures like all like that. And honestly, I think this looks a little bit more natural anyway. I think this setup looks a little bit better. So yeah, so now let's go ahead and work on collisions. So this is the idea I had. There's going to be I'm going to show you how to make at least 5 different collision types here. So we have, and I'll actually open up our game again to show you. exactly what I'm thinking here. So we have the whole full block collision type, and actually in our game, I don't know if we have a block that has a. Maybe we can use the water, where you collide on every side of the water texture. And right now I'm placing it on layer 2, and it should be on layer 1. But you get the idea. You collide with all sides of this, right? And then we have the collide above, which the collide above's like the top of this tile. I don't know if I have an example of that here. We will soon, though. We can show an example. And then we have the only thing I guess I have a good example for is the collide below, where for the tree we want to collide at the bottom of this tile. But let's just start with enabling collision in general. So what we're going to want to do is we want to go to our tiles.txt. We have sprite x, we have sprite y, and then we have collision type. Okay, and collision type. If there is no collision type argument, then there is not going to be any collision. So I'll go ahead and put another comment. If there is no collision type argument, that tile has no collision. Okay, so let's go ahead and think about this. The tree bottom is going to have collision type of, and if I'm laying out like I did in that image, which I closed for some reason, but I have it right here, it'd be 0, 1, 2, 3. So the collision type of the tree bottom is going to be 3. We'll make the water collision type of 0 for now, which is just kind of our test tiles. So now what we're going to do is we're going to go to where we're loading our map, and not our map, our tiles. So where's that? Tiles.java. Yep. And sprite x and sprite y were the two parameters we had, and then I want to do an if if split string dot length is greater than length is greater than or equal to is it 4? 1, 2, 3, 4. Yep. It's 4. Then we want to do tile public boolean collidable equals false. We'll set to false by default. Public int collision type equals -1 by default. And we'll do tile.collidable equals true, and tile.collision type equals integer dot parse int split string of 3. Okay, so that will get the collision type, and then we want to check collisions not all the time, but only when the player the player moves, which will end up being like whenever the game object moves. So what we could do is, if we want to also make it so that this works for like mobs and stuff, and like stuff we add later, we could in the game object have like a move field as well, like a move. What am I thinking of? Like a move check. But for now, we're just gonna work with the player. So this is in the update method is where we're checking to see if we can move. So right now we have player rectangle.x sets equal to speed, and we're sort of just doing that. What we want to do is we want to go ahead and set these to variables. So we have new direction here. Let's go ahead and say int new x equals 0, int new y equals 0. And then we want to go down here, player rectangle.x. Instead of that, it'll be new x. Oh, sorry. We'll set this to player rectangle.x, and then player rectangle.y, and then we'll do new x minus equals speed, new x plus equals speed, new y minus equals speed, and then new y plus equals speed. The direction will be the same, because even if we collide with something, we still want the direction to change, even if we move. So, and I guess the animated sprite we could keep the same as well. So if we're running, we're sort of running, but we're colliding with the wall. That could be interesting. So anyway, we have this update camera method here. So let's go to if we want to do if. What I want to do as well is I want to go ahead and create another rectangle called the collision check rectangle. And the collision check rectangle right down here, we're gonna go ahead and do collision check rectangle dot equals new rectangle 0 0, and the width and height of the player, the same width and height there. So good there. And then we can go down to update and set that collision check rectangle. And actually we'll use collision check rectangle.x instead of so we'll have collision check rectangle.x and then collision check rectangle.y, and then we'll set the new x to that and the new y to that. So we're replacing new x and new y with that. What else do we want to do? And then finally, if we did move, so down here, if we did move, then we want to check to see if we collided. So we want to do if, and this update camera we should probably put in did move as well, because there's no reason to update the camera if we didn't move. So if you want to do game dot check collision, and then we want the game object, and then we want a rectangle. And the reason why we want the game object is we want the layer. And actually what we could do is just do, we could just pass in a layer. Do we have the layer saved here? Oh, we're just saying it's 0. Okay, you know what, let's make a field for that here. Private int layer equals 0 for now, and we'll return layer in the get layer instead of just 0. So we want to update, we want to do game check collision, which is a method I haven't created yet, and we'll make a layer. We'll pass in the collision check rectangle and then the layer, and this will return true if there is a collision. So if there isn't a collision, so I put an exclamation point there, if there isn't a collision, we want player rectangle.x to be equal to collision check rectangle.x, and player rectangle.y to be equal to collision check rectangle.y. And then we can also pass in this stuff. So actually what we can do is just do if did move and, oh no, you know what, I decided I changed my mind, because what I want to do is still update the animated sprite so it looks like the player's just moving into the wall, because that's sort of the feel I'm going for. It's up to you though. Cannot find simple because we haven't created it yet. So let's copy this into game, update, render, change tile, get selected tile ID. We'll go ahead and just put it here. Public void, or public boolean, check collision, and then we have rectangle, collision check rectangle, and int layer. And what we want to do is map.check collision of, and actually, do we have a get map method in here? Okay, we'll make it public map get map, return map. So what we can do is just make this method in the map class. Public boolean check collision of rectangle, collision check rectangle, and integer layer. And we'll just, instead of getting collision check rectangle, we'll just call this rectangle. Or rect, whatever. And what we want to do is first of all use the same math to get tile. So you want to do mapped tile, tile equals get tile. We want to get a few tiles here. We want to get the tile to the left of the player, We want to get we don't want to just get the tile at the player's position. We want the tiles around the player. So specifically, we want to check. I guess if the player is, let me go ahead and run the game. Let me just go ahead and. Oh yeah, there's something. It's not gonna let me move, is it? Get map dot check collision. Map.java. And right now we're just gonna return false from here. Say there's never a collision. Whoa. Oh. I think I know why that happened. Hey, no, I don't know why that happened. Set to... Oh, it's because I guess I'm not updating the camera right at the start. So maybe we need to do just a call to update camera. Or, guess we could just call update camera every frame. I feel like it might be needed for other things. Okay, so anyway, as I was saying, I'm just gonna lay out sort of a map of different things I could collide with. And speaking of colliding with things, I'm gonna go ahead and set it so that we are setting tiles on layer 0. So it all will render behind us, and it's technically on the layer that we are on. So let's do. So if I'm standing here, the maximum amount of tiles that my player at least can be on is 4. Now depending on the size of your mob, that might be different. And actually, now I think about it, we could do some math with the width and height of the player and check all the tiles possible. I guess yeah, you know what, that might just be easier. So for different sprites, this will work out. So let's go to, back to our map.java. And instead of returning false, what we're going to do is for int x equals 0, x equals rect.x, x is less than rect.x plus rect.width, x plus equals 16. So this is, we're not zooming at this point. Rect.x is zoomed, but it doesn't matter because we're adding it to both. Actually, we could also just do this. And then for int y equals 0, y is less than rect.height, y plus equals 16. And we'll add another. We'll make it so that it goes up to 1 tile past the width and height. I don't know if we'll do that. Okay, I don't know if we'll worry about that right off the bat. But we want to do mapped tile equals new mapped tile, or new mapped tile. What am I doing? Equals get tile of layer, and then the tile x is going to be x plus rect.x, which is already zoomed, y plus rect.y, or no, it's not zoomed, is it? The x isn't zoomed. We'll do x times, and we don't have an x zoom variable, do we? Do we need it to be zoomed? The rect.x is technically zoomed, that's the issue. We need to divide rect.x by x zoom. So we need X zoom and Y zoom, and we'll figure out later how we're going to get that. So I'm going to do rect.x divided by X zoom and rect.y divided by Y zoom. And then so we'll get that tile. And if mapped tile dot, we have the tile ID saved in mapped tile, and that ID will we have to get that ID from the tiles class and check to see if we collide with it. So, do we have access to those tiles here? Wait, thought we did. Checking how am I rendering them otherwise? This be in block, wouldn't it? Tile set dot render tile. Yeah, tile set. So tile set is up here somewhere. Must be. Yeah. Okay. So tile set dot get tile. Or yeah, render tile. Not get tile, but tile set dot public boolean public int collision type of int tile ID. We want to do I'm going to copy this. Oh my gosh, I'm doing C stop bracketing again, aren't I? I'm going to copy that if and else statement. But instead of render sprite, I want to return tiles list dot get I dot or get, sorry, tile ID dot collision type. We'll have a return -1 there. So this is going to be -1 if it's not collidable. So we don't necessarily have like that collidable boolean, but we'll keep it there just cause. Might be useful at some point. Where were we? Go down to the check collision method. Maps tile tile is a get tile, and all that jazz. Yeah, so we're getting the tile, and we want to do if tile set dot tile or get collision type of tile dot ID does not equal, or yeah, does not equal -1 for now. Then we want to return not necessarily return true right off the bat, but we want to go ahead now and create a rectangle for this tile. Rectangle tile equals I'll set this to a variable because there's different collision types. So int collision type equals tilesat.get collision type tile.id. And if the collision type is equal to 0, which was this remember the full tile collision type, so we just want to see if we want to create a rectangle for this tile and see if it intersects the player rectangle. So rectangle tile rectangle is going to be equal to new rectangle, and we have the tile.x, tile.y. I want to do times. We'll have two variables up here, and we can copy the tile width and tile height calculations from here. Tile x times x zoom, tile y times y zoom, tile width and tile height. So that gets the rectangle, this tile's rectangle in its position, and we're just going to see. We have remember that intersects method we made that was very useful? it's become even more useful at this point. That is the entire basis of our collision is this intersects method in a rectangle. So let's go back here and do if tile rectangle dot intersects rect. Then we want to return true because we have a collision. And we're not going to return false else here, otherwise it will not check the other tiles. We just want to put the return false down there, which means that it hasn't collided with any tiles that we've checked. So did we not? Okay, so we just have, I guess, the collision type, not get collision type. So that should work. So now we should collide with any of the tiles that... Oop. Oh, okay. So map is... Our player is... We need to pass in the X zoom and Y zoom. Which do we... I guess we don't... Okay, well, we do have. It will be game.xzoom. Do I have that as a public? Private int. Let's do public int get x zoom, return x zoom, public int get y zoom, return y zoom. And then in player we'll have game.get x zoom, game.get y zoom. And then we'll run our game. I'll point to exception in map.java 143. Int collision type equals tileset.collision type tile.id. Oh, I have to make sure if tile does not equal null, then all of this. Control tab. Oh wait. Tab. Because otherwise it will be null, funnily enough. So we're checking these waters should have collision type 0, right? Is that what we had set in our tiles.txt? The water was collision type 0. Doesn't seem to be working though. So we'll work through this error. First of all, let's print line here if we actually do find a tile in the area with collision type of 0, because we want to check to see if that is the issue. Okay, so it's never actually coming across this tile, so we know that to be the issue, unless... Yeah, okay, so it's never finding that tile, which is probably the start of our issue here. So let's see, we're looping through from x equals 0, x is less than the width of the rectangle and the height of the rectangle. So we'll do, first of all, check here to see if we're getting there, because maybe for some reason we're not. Better safe than sorry. And for this kind of debugging, I'm just going to go ahead and open up a terminal here so I don't have to keep going back to the game class. And all I'm doing is on my other monitor typing in Java game to run the game. Oh, so it's not even getting there. Peculiar. Is the rect.width and rect.height set correctly for the rectangle I'm passing in? We're using the collision check rectangle. And the collision check rectangle has a width of 20 and a height of 26. It should do anyway. So if we go back to map.java. See if it... Oh wait, no, the high's being printed out on my other. I forgot that it's not going to print out in Sublime Text. So that was, we're getting here. What's not happening is, let's see if, are we finding tiles that are not null? That's our second check here. Okay, so there's our issue. Every tile it's finding is null. So that would be an issue. Um, oh, we need to do. Wait, no, that should work fine. We're having rect.x divided by x zoom to remove the zoom. Unless get tile removes the zoom as well. No, it doesn't. Let's do a print line here. I'll get rid of this one. See what that looks like. Those are huge numbers. So I'm looking at numbers like 149 and 22, which are not tiled positions. So there's something definitely wrong here. Wait, yeah, they wouldn't be time positions. I'm just dividing by x zoom. We want to divide it by tile width and tile height, right? Because we want the tiled position, not necessarily just the unzoomed position. And that looks like the numbers are not bad. So now let's see if we can get to this part. Okay, looks like it is. And I'm getting the found tile, which is good. So it's getting to this found tile part now. So I'm gonna go ahead and make sure it's doing that at the right times, because it collides with the water. Okay, so something's a little off. Okay, so the tile rectangle is definitely a little off. I think what we should do is in the player.java, we'll make this we need to make this zoomed, so we should probably can't do it here because it'll add it every single time. I just need to pass in the x zoom and y zoom variables to player, I guess. X zoom and y zoom, and that's gonna have to change in game, which is on line 108. We want to pass in x zoom and y zoom, and now when we run our game, see how it's printing out weirdly. Let's go back to the map and figure this out. So we're getting to this part where we actually find the tile. Now the rectangle is the part. Well, actually, now I think about it, I think the problem is when it's printing out, not. And I think what we might need to do is x equals -16, y equals -16. And then rect.width plus. Okay, that might be another thing. So if we put it over there, No, okay. -32. It's not. That's really weird. I'll figure it out. I'll be back. It's a while later. I want to get this lesson finished. I've been very busy recently. I fixed up this check collision method. I'm not entirely sure why I left off, but this is how I got it working. There's actually another thing that I would need to fix as well, but I'll leave you with this for a while first. So pretty much what I have is coordinates to check all the tiles in a radius of 4 around the player. So 4 to the left of the player, and then 4 to the right of the player, 4 above and 4 below. What you do is you have a top left set to rect.x minus 64 divided by the tile width. So these x and y positions are tile x and y. And I think in that original implementation I had them mixed up. Oh no, I was getting pretty, I was making a lot of mistakes at the end there, and one thing to remember is if you're programming and you're just making lots and lots of mistakes, sometimes it's best to just take a break, honestly, and come back and look at it with fresh eyes. So anyway, the bottom right x is the rectangle x plus the width of the rectangle in question, because remember, this check collision method can be applied to everything, not specifically just the player, which is kind of cool, actually. And then 64, I'm adding 64 to that as well, so that it's 4 to the right and 4 below. And I divide all that by the tile width and tile height to get the bottom right x. And then my 2 loops here will loop through both the x and the y, between the top left x and the top left y to the bottom right x to the bottom right y. And I'm adding 1 each time because, once again, these are tiled positions, so I can actually just do x plus plus instead of x plus equal 1, but yeah, might as well do that. And then I'm getting the tile at that position by just using get tile layer of x and y. And the layer is the provided layer. And if the tile is not null, then we want to get the collision type of that tile. And that was where the first mistake came in. I only implemented the collision type of 0. And if we look at our tiles.txt, this was originally 3. But for testing purposes, I'm going to set it to 0 for now. So all the collision types are at 0. So water, I put the collision on the water just for testing purposes. And actually, it makes sense as well. Okay, so, and then what we do is we form a rectangle to use the intersects method just for our final check. Because remember, this is looping through all the tiles in a radius. So even if the collision type is equal to the one we're looking for, we still want to make that rectangle. So pretty much we have tile rectangle equals new rectangle. The tile x position times tile width, and the y position times tile height. But because the rectangle that we're passing in is, we're assuming it's not zoomed, we're just going to use 16 and 16 for the width and height of the tile. And that's worked out for me. And then we finally do the intersects call, and if the tile rectangle intersects the rectangle, we want to return true. All right, so now we're going to go back to player as well for the second mistake, which was that I was only checking layer 0, not layer 1. So if we go down to the collision checking, I've decided that I want the player to collide on both the layer 0 and layer 1. And maybe if I need to layer anything over that I don't want the player to collide with, I'll put that on layer 2. So what I'm doing is just 2 of this check collision call, 1 for layer, which is 0, and then 1 for layer 1, which is 0 plus 1, so layer 1. And if either of those are true, this will not go through. I'm ending these 2 calls and I'm putting a not before them. So if either one of these are true, the player will not move. And we will try to. There's a really easy way to make it so this allows the player to move on certain axes, but not others. But we'll start with this. So now let's go to our game here. And as you can see, we collide on all four sides of this tree stump, but not the top of the tree. If it's not that accurate for you, it's because we need to work on now the player's collision rectangle. So here's the water that I'm supposed to collide with, and as you can see, it's a little weird. So first of all, we need to go to all four corners of this and isolate them. So first of all, I'm actually starting to think that the player, I think what we want to do is if we go back to our map here, the width and the height needs to be tile width and tile height, but I think something else is messed up. So that was kind of where I ended with my debugging right here. So if we set that back to tile width and tile height, we will collide on all four sides, as you can see, but I think the player's collision box needs to be reduced. As you can see, we can't actually go through the tile at all. So to reduce the player's collision box, we pretty much need to go into our player, and at the very top where we create the player rectangle, first of all, the X and the Y are just the starting positions, but the part that we need to worry about is the collision check rectangle. And actually, yeah, so we are incorporating the zoom right here. My bad. And the collision check rectangle. So we need to reduce it looks like the left side. So if we just move this down to like 15, for example, that should mean we'll have to sort of just go through it a few times, figure it out. Okay, so that's a little nicer. Another thing I want to do quickly, actually, if we go back to the player, is I want to go down to the where we're checking in the collision check rectangle, and we have this collision check rectangle X, and I want to be able to offset the X and Y as well by the collision rectangle. So I wonder if we could just have variables like private static or private final int X collision offset Y collision offset, and we'll set these up here. Private final int Y collision offset equals 0. All right, and then what we can do is before we pass in this collision check rectangle to this method, we just want to do collision check rectangle dot x plus equals x collision offset, and then collision check rectangle dot y plus equals y collision offset. And the reason I'm doing this is because we need to offset pretty much this 20 and 26 was how we originally divided the player sprite, but the actual collision rectangle for the player is not going to be exactly that. So let me just put this down to like 10 and we'll play around with it. So let's go back here. Doesn't seem to have changed much. It probably did on this side. Yeah, there we go. So we have 4 fields here, right? We now have the X collision offset, the Y collision offset, and then the width and the height. So the width and the height are gonna be for well, the first thing. Sorry, I'm going all over the place, but the first thing we want to change are the X and the Y collision offsets. So looks like this is, if I offset this by like 10, maybe it'll be a cleaner collision. And this is going to be different depending on the sprite you're using. And holy cow. Huh. Should only be happening once, right? That's odd. Okay, so this is a little strange because collision check rectangle at X is being reset every time. Let me just set to like 1 and see what's happening. Oops. Let me open that up again, and I'll take a look at it. Oh, I see why now. It's because after I'm doing the offset, I'm actually setting it down there. So if we set that offset again to like 10, what we want to do is collision check rectangle minus X collision offset, and then minus Y collision offset. There we go. So we're sort of setting an offset for where our collision is being checked and where our player is moving. So now, as you can see, we're more flush to the edge of the tile when we're attacking from the left. But as you can see, the offset on the bottom has to definitely be increased. So the reason why I'm doing these two X and Y collision offsets first is because the width and the height is going to depend on these two. So looks like we want a pretty significant offset down here. Let's take a look at that, see if that changed anything. Okay, that looks pretty awesome actually. And then, okay, so it looks like I got the width, I guessed the width pretty alright, but as you can see, the height needs to be changed quite a lot, so let's move that down to like 15. Okay, and I think the next thing might be just to move the X collision offset over by like 1 pixel. Okay, maybe a little bit more. Let's try like 13. Oh, wait, am I going in the... I feel like it's going in the opposite direction, but maybe it's just not changing significantly. Okay, so that's a little too much. Or is it? I don't know. Doesn't seem too bad. Maybe we'll bring it back to like 14. And it really is just like keep checking. The reason why I did the 0 collision type first, where we just have the big tile like this, is because you just need to keep sort of like, you have to figure out first of all your player's collision square. So now we haven't actually changed the collision type for these yet. So as you can see, it's not how I want it to be. But let's go down. I think, yeah, okay. So here are the collision types. It's been a while, so I need to take a look at these. So the 0 was for the water, which we had those. The tree bottom is going to be 1, 2, 3. So we're going to have, oops, the tree top. What did I just change? Okay. Yeah, the tree bottom is going to be the third one, so 0, 1, 2, 3. So let's go back to the player now, or sorry, the map, and let's go ahead and make that. So if we go to player.java, we're going to, or sorry, map.java. We're going to go down to where we're doing the collision checking and make this look a little cleaner as well. So else if collision type equals 1, and we haven't programmed that yet, so we'll leave that blank. Else if collision type equals 2, return false, and let's just skip to the third one because that's what the tree is going to be, and we can just test that. So I think the plan I had was the bottom of this is going to collide with the bottom of the player. The bottom of this is not going to collide with the top of the player. It's going to be the bottom of the player. And it's, you know, you can have multiple collision types for both options. But this is how I'm going to do it. So we have 2 rectangles here. The rectangle, tile rectangle, equals new rectangle, and we want to do tile.x times tile width, and then we want to do plus tile width, like, no, sorry, that's fine. And then we want to tile.y times tile height. It's going to be times tile height plus tile height. so that we offset, you know, all the way down there. And just for good measure, we'll do a -1 because that would technically offset it by 1 more than it needs to be. And then the tile width is going to be the same. The tile height is going to be 1. Okay. So what this should do is make it so the very bottom of the tree trunk is being the very bottom of the tree is being collided with. And I do want to address the tile of the rectangle for the player, but first we'll do this. So intersects rect, return true. Just to test that theory out. So now I'm going to just go isolate this tree trunk. We should only collide, as you can see, with the bottom of it. And our player is colliding... yeah, okay. And I'm putting this on the wrong layer right now, so that's why it's displayed weird. But our player is colliding with the bottom of it, and then what we'll do is we'll subtract maybe a little bit more, just because I don't want the player to display in front of the. So if we go to map here, just gonna subtract like 5 from that instead of 1. We'll see if that changes anything. Oh, still needs a little bit more. Oh, maybe not. Huh. Why is it happening? Okay. Let's try a little bit more then. Let's just do like 8. Let's try 8. Why is it working down here? Don't make sense. It's totally fine down here, but up here it is. Yeah, it's odd. Okay. For testing purposes, I'm just like going to subtract like 16. Because I don't know why this is happening. Okay, so that's... Actually, that's alright. I'm okay with that. So the line is moved a little bit higher. And then what we can do is... we can make this a fatter rectangle as well. So... we can make this like 16 instead of... what it is. It's a little bit like tall, but not too much. Okay, and then what we want to do is make an adjusted rectangle for the player that's colliding. So rectangle adjusted rect equals new rectangle rectangle. What? How do I spell this? That's just, wow. New rectangle. And we want the X position of the player is going to be exactly the same. Y position is going to be rect.y plus rect.height. And then the width is going to be rect.width. The height is going to be I guess 1. Oops, tried to run players again. Oh, I'm still colliding with the original rectangle. And then we need to do tile rectangle that intersects adjusted rect. There we go. So as you can see now we're behind the trees and we're colliding with the bottom of it over here. And then when we're in front of it, we can sort of walk in front of the trees a little bit, and it's sort of like a clean sort of like collision. It's not, the top of our player isn't colliding, but it almost seems as if the bottom of our player, like our feet, are colliding with the tree. So it gives the illusion that we're standing on the same level as the tree, which is exactly what I'm going for. So there we go. So let's work on some of the other collision types as well, just cause, and I'll test it on this water. So collision type 1 is when we're colliding with the top of something. Now actually what we could do, and just because this, I mean, this lesson's gone on for a very long time, and I might as well just have it go on a little bit longer. Why not? Let's add some more tiles to our game. Let's go into our tiles 1, and let's add these walls. Or the walls that I want, actually. Okay, actually I just realized that the tile set that I want to use we're not even using it yet. So for now, I will just test them with the tiles that we have. So, what do you mean you can't view the image? There you go. We'll go to tiles 1 and we'll set the water to collision type 1 in the tiles.txt. And we'll go to the map and okay, and rectangle, tile rectangle in this case. This is where we're colliding at the top of the tile. Is going to be tile.x times tile width, tile.y times tile height, and it's going to stay there. And then we want the width to be tile width and the height to be, we'll go with that 16 again. And let's see how this looks. So the water is colliding like that. Oh, I'm not even, wow, I'm just on a roll today. If tile rectangle dot intersects, and we'll just use the normal rect for now, return true. So we collide with the top like that, and our head's colliding with the bottom. I think we want to do, I think that's okay. I think we want to stick with that. So we collide with the top of it, and we still overlap at the bottom. I think I want to stick with that actually. So we'll keep it as it is. So now collision type 0 and 2, where we're colliding with the side. We'll set our water to that for testing purposes. And now we'll go back to our map. Rectangle, tile rectangle equals new rectangle. In this case, it is tile.x times tile width, tile.y times tile height, and then the width of the rectangle is going to be that 16 number again, and the height is going to be tile height. And then if tile rectangle dot intersects with the rect, return true. Okay, so now we're colliding with the left of the tile. I think that's all right. If that needs changing once we implement the tiles that are actually going to implement these, then go ahead. You can adjust those numbers to satisfy your needs. So we only have one more collision type now. Oh, sorry, no, we have one more. So it's collision type number 4, 0, 1, 2, 3, 4. Where we're colliding with the right side, so let's set collision type to 4. And add another thing here. Collision type equals 4. Rectangle, tile rectangle equals new rectangle. And we're going to do tile.x times tile width plus tile width minus 16, because 16 is apparently the lucky number. And then the y is going to be tile.y times tile height, as it was before. The width is going to be 16, and the height is going to be tile height. And if tile rectangle dot intersects with rect, return true. And let's give this a try. So we're colliding with the right side. And you can still come from the above like that and potentially still collide, and same with the bottom, because it has a little bit of a girth to it. But there you go. And now I'm going to go ahead and reset the water to collision type 0, because that's what makes sense for water. Possibly not this water. What the heck? Oh, I was trying to compile it. Possibly not this water, because this water kind of seems like a what did I do? Okay. This water sort of seems like puddle water, not necessarily actual like lake water or, you know, pond water, whatever. But yeah, so we collide with all of this, and we have this nice little tree collision. So one final thing is we want to make it so that if I was to collide with this tree, I can't move down, but I can move to the right. And there's a really easy way to do this, and it does require more sort of runtime, I guess. But it's not too bad. So what we want to do is sort of isolate the axes here. And to do that, we're going to just reset the... we're going to do two checks, one for the x-axis and one for the y-axis. So we'll have rectangle x-axis check equals new rectangle. And we'll have collision check rectangle dot x, and then we'll have the y will be what it was before. So player rectangle dot y. The width will be collision check rectangle dot width, and the height will be collision check rectangle. Yeah, collision check rectangle dot height. And we'll just call this axis check because I'll use the same rectangle for the y-axis check. And then what we want to do is this will be check the x-axis. So we'll pass in this axis check rectangle, and we'll only change the x. Yeah, we'll only change the x there. And then we'll make another one for check the y-axis, and in this one we'll only change the y. So rectangle.y equals collision check rectangle.y, y collision offset. And in between these two, I want to move down this axis check rectangle. So we have collision check rectangle dot, we have player rectangle dot x, collision check rectangle dot y, and then the width and the height is the same. And actually, what I'll do is, I'll just do that. And now if we run the game, as you can see, we can sort of like move across like that. It's not doesn't do working here. I think I know why that's not working. So wait, maybe I don't. Yeah, because let's also make it. Let's not create another rectangle just because we'll do axis check dot x equals player rectangle dot x, axis check dot y equals collision check rectangle dot y, axis check dot width equals collision check rectangle dot width, and axis check dot height equals collision check rectangle dot height. About that, I had to leave the computer for just a minute. So let's take a look what the problem we were having was. So it works down here. I kind of like slide across. Out of curiosity, what? Let's try a bunch of water and see what happens. Okay, so we can't slide that way for some reason, or that way. We can slide this way and this way. Huh. Don't really know why that's happening actually. Oh, it might be because of the offset, maybe. The collision offset? No, I wouldn't be doing anything. So we're just using the player rectangle dot y in this first axis check. We're just using the collision check rectangle dot x. Excuse me. With the player rectangle dot y. Maybe we want to still use the collision offset. Maybe that's why. Plus x collision offset. That might be why. That's probably why. So if I go ahead and make that, I'll make it a block of water. Yep, I can slide that way, and I can slide in all four corners. So now we can slide sort of down the trees like that, and we can slide up them like that. So there you go. You've isolated the two axes and stuff. So there you go. Awesome. So yeah, that's pretty much. I'm gonna go ahead and put comments in here because I don't comment enough in these lessons. But it's mostly just because I want to get stuff done. This was like, if I was doing this for like a job or something, I would definitely use a lot more comments. But we'll go ahead and say full tile collision. The collision type 1 is the top of tile collision. Collision type 2 is the left of tile collision. And then collision type 3, as we know, is the bottom of tile collision. Collision type 4 is the top of tile, or right of tile collision. And there you have it. That is pretty much it for this lesson. This has gone on for long enough, I think. We've implemented all forms of those four forms of collision. Hopefully you guys understand how you can implement your own forms of collision just by adding another collision type and doing whatever you want with that. Obviously our player is too big to fit within a tile gap, it looks like, which is, I mean, it's probably what we want. So yeah, we got advanced layering done. We've got tile collisions done. That's about it. If you guys need anything else, go ahead and comment and I'll see if I can help you out. And we'll see what we can work on next. Maybe at some point, I keep saying this, I think I said this in the 7-hour episode, but lesson. But if you guys want, I can actually make a game of this at some point. I feel like that might be something that a lot of people want me to do. But let me know. I have a few ideas for games that might be easy to make. But yeah, just some ideas for stuff that you guys might like or might be useful to you. Different AI stuff. I don't know. Lighting. You guys pick it, and I'll try to work on it. I have done some AI work before, not as extensively as graphics and physics and stuff, but I've given you guys the blueprints to make your own games. So have fun with it. Let me know what you need help with. And try to work on it yourself as well. See what you can create yourself. That's the whole point of this anyway. Anyway, guys, thanks for watching.